Howdy folks, welcome back to Wrath of Math. After a hurricane and a power outage, I am back here in the home studio and everything is as it should be. We got the whiteboard, we got the lights on, and we are doing a viewer requested video. In today's Wrath of Math lesson, we're talking about finding the difference between two polynomials. We got a polynomial here and we're subtracting another polynomial. Polynomial minus a polynomial. So we're finding the difference of two polynomials in today's Wrath of Math lesson. I always appreciate those viewer requests, so be sure to leave yours down in the comments. Now, of course, we'll spend a lot of time studying polynomials. They're pretty important, so it is important as well that we're comfortable working with them. Now, when it comes to subtracting two polynomials, there's really only two things we need to focus on. There's two things we gotta know, which we should already be familiar with: the distributive property and combining like terms. And we'll see both of those in action in today's lesson. So if you're rusty, don't sweat it. Hopefully this will help make everything clear. Let's just jump into the example. And again, it's a pretty straightforward two-step process. We use the distributive property, we combine like terms, that's our answer, bada bing, bada boom. And yeah, so let's do it. We've got 2x cubed plus 3x squared minus 4. This is one polynomial, and then we're subtracting this other polynomial. So the first thing we want to do is get rid of these parentheses. And in order to do that, we just need to distribute this negative throughout the polynomial. So basically, just multiply everything in here by -1, and then we can look at this as one big polynomial and start to simplify it. So if we just focus on this side of things, the polynomial that we are subtracting, again, we distribute the negative. So instead of x cubed, we're going to have negative x cubed, negative x cubed. Instead of negative 2x squared, we multiply that by -1, we have positive 2x squared. So that's plus 2x squared. Instead of plus 6, we multiply that by -1, distributing the negative, giving us -6. And then we can write this part of our polynomial, which isn't changing during this step. So we've got 2x cubed plus 3x squared minus 4, and we're subtracting this polynomial. We've just distributed the negative to get rid of the parentheses, and now we've got that. Beautiful. Now we just combine like terms, and that's our answer. That's all there is to it. Remember, combining like terms, it basically, so look at this, right? 2x, we got a 2x cubed and we got a minus x cubed. So we can combine those to get 1x cubed. And there's nothing special about these variables. If you find it confusing, think about any other sort of objects in life. If we had 2 apples and -1 apples, or giving an apple away, you could combine those counts to be just 1 apple. Whereas if you had 2 apples and you gave away 6 oranges, you couldn't really combine those numbers because they're not like terms. So we can combine the like terms to simplify to get our final answer. We have 2x cubed minus x cubed. They're like terms because they have the same variable coefficient, x cubed. So 2 minus 1 is positive 1. So we just have 1x cubed. Then we have 3x squared, and we see we also have a plus 2x squared. 3 of something plus 2 of something is 5 of something. So 3x squared plus 2x squared is 5x squareds. So we've got plus 5x squared. Let me take a deep breath, keep talking real quick. So what do we have left? Well, we got some constants. These have a variable coefficient of x to the 0, we could say, because x to the power of 0 is equal to 1. So we could say that the constant, -6, has a variable coefficient of x to the power of 0, which is the same as -4. That also has a variable coefficient of x to the power of 0, but that's just a little technicality. It's not super important. So these are our constant terms because they're not getting multiplied by a variable, so we can combine them. -4 plus -6, -10. And so that's it. That's the answer. We got the -10. And finally, we see the difference of these two polynomials, 2x cubed plus 3x squared minus 4, minus the polynomial x cubed minus x squared plus 6 is x cubed plus 5x squared minus 10. Beautiful. So hopefully that was fairly clear, and I encourage you to give this next one a try on your own before we get into it. All right, let's get into the second example. All we have to do is distribute the negative and then combine like terms as we just did. These caps are always kind of hard to take off and they squeak really loud. So let's just distribute the negative throughout this polynomial. We've got 3/4 x to the fifth minus 3x cubed plus 2/3 x minus the polynomial 1/2 x to the fifth minus 4x cubed plus x squared minus a fourth. Just got to distribute the -1 throughout this polynomial, and then we can rewrite this as one polynomial without the parentheses. So let's see it. -1 times 1/2 x to the fifth, that's going to be minus 1/2 x to the fifth. -1 times -4x cubed, negative times a negative, that's a positive 4x cubed, so we've got plus 4x cubed. -1 times plus x squared, that's going to be minus x squared. And then we've got -1 times -1/4. Negative times a negative is a positive, that's plus 1/4. And then the left part of our polynomial, which is not getting subtracted, we can just drop right down unchanged. So we have 3/4 x to the fifth minus 3x cubed plus 2/3 x. And then all of this stuff that we just found out by distributing. Now it looks a little messy, but all we got to do is combine like terms as we did before. We're going to have to find some common denominators for this simplification. You should be comfortable with finding common denominators. If not, look up a lesson on it. I might have one, I'm not sure, but I just want to say I'm going to go through that pretty quick here because you'll want to be familiar with that, and I'm going to assume that you are. So we've got 3/4 x to the fifth, and we want to look for the other x to the fifth term if there are any. We see there is. There's a minus 1/2 x to the fifth, so we can multiply this x to the fifth by 2/2 so that it's minus 2/4 x to the fifth, and then we'll have common denominators here. So we would have 3/4 x to the fifth minus 2/4 x to the fifth, and that would be 1/4 x to the fifth. So we've just got 1/4 x to the power of 5. Moving on to the next term, we've got minus 3x cubed. Do we have any other x cubed terms? Yes, we do. We've got a plus 4x cubed. So 4x cubes minus 3x cubed, that's 1x cubed. So we've got plus x cubed. What else have we got? 2/3 x. Do we have any other x term? It does not look like we do, so we have nothing to combine that with. We can leave it as it is, just plus 2/3 x. Then we've got the minus 1/2 x to the fifth. We already combined that with our first term, so we can ignore that. It might be helpful for you to cross off the terms as you combine them, so we could do it just like that. Then all we've got left is this stuff, and we see there are no like terms there. In fact, we already used the 4x cubed, and then all we have left is this stuff at the end. We've got nothing to combine it with, and so we are left with negative x squared plus 1/4. And that is the answer. And if you wanted to, just because it might look a little nicer, we could flip the x squared and the 2/3 x around, because it's kind of nice to write the polynomial with its terms in decreasing order, with the exponents in decreasing order. So we might write this, instead of 2/3 x minus x squared, we could write it as minus x squared plus 2/3 x. And that would be our answer. So that's all there is to it. To find the difference between two polynomials, to subtract two polynomials, we just use the distributive property to distribute the negative throughout the polynomial that's being subtracted, and then we just combine like terms and we get our answer. They might look a little bit messy, but I think you'll agree the process is pretty straightforward. Stuff that we've done plenty of times before. Now quickly, I just want to find this difference of polynomials one more time, but a slightly different way. If you're feeling very comfortable, you might find this way to just be nicer and easier. Basically, this way we kind of combine the two steps into one. So here's how I might do it. I'd say, okay, look, we've got 2x cubed. Are there any other x cubes? Yes, we've got an x cubed over here. That's getting subtracted, so I know that's just going to be an x cubed. Then we've got 3x squared. Do we have any other x squared terms? Yes, we've got minus 2x squared. I know we're going to subtract that minus 2x squared, so that's going to be a plus 2x squared. And so when I add that to my 3x squared, that's going to be 5x squared. Then I've got minus 4. Do I have any other constant term? Yes, I've got a plus 6. I know that's going to be subtracted, so minus 4 minus 6, right? We've got the negative 4, which I like to call minus 4. The negative 4 minus the 6 is going to be the negative 10, and bada bing, bada boom. There's the answer. So that's another way you might want to do this. If you're very comfortable with it, you can sort of just combine the steps into one, and there we go. So hope this video helped you understand how to find the difference between two polynomials. Be sure to let me know in the comments if you have any questions, need anything clarified, or have any other video requests. Thank you very much for watching. I will see you next time, and be sure to subscribe for the swankiest math lessons on the internet.